We'll take a look at the greatest common factor, and we're going to focus on the prime factors method. Now we'll describe the greatest common factor, look at the steps in finding the greatest common factor, and this is going to be using the prime factor method, and then we'll find the greatest common factor of a set of numbers using the same method. So the greatest common factor is the largest common factor taken from a set of numbers, and the greatest common factor of a set of prime numbers is 1. So to find the greatest common factor, we'll first develop factor trees for each number, express each of the numbers as a product of its prime factors, and we will identify the prime factors and then multiply common prime factors together to determine the greatest common factor. Now let's apply those to some examples. So we have, what is the greatest common factor of 15 and 27? So we're going to draw a factor tree for 15. We have 15, 3, 5, and then for 27 we have 3, 9, and then 3, 3. So we have 15 is equal to 3 times 5. 27 is equal to 3 times 3 times 3. So what we're going to do now is, to get our greatest common factor, we're going to only deal with numbers that appear in each of the numbers. So we can see we're looking at prime factors that appear for each of the numbers given. So we can see 3 is a common prime factor here. There's nothing else that is common. So GCF is equal to 3. Let's look at another example. So we have 16, 20, and then we have 28. So 16 we have 2 times 8, then 8 is 2 times 4, 4 is 2 times 2. So 16 is 2 multiplied by 2, multiplied by 2, multiplied by 2. Let's look at 20. We have 2 multiplied by 10, and then 10 is 2 multiplied by 5. So we have 2 multiplied by 2 multiplied by 5. And then 28, we have 2 multiplied by 14, and then 14 is 2 multiplied by 7. 28 is 2 multiplied by 2 multiplied by 7. So we can see here we have 2 that is common. So our greatest common factor is going to be 2 multiplied by, so we have 2 again, and then we have nothing else that is common for all 3 numbers. So this is going to give us 4. Another example. What is the greatest common factor of 36, 54, and 90? So we have 36, 54, 90, and then we're going to look for the greatest common factor. So 36, let's create the prime factors. We have 2 multiplied by 18. 18 is 2 multiplied by 9, and then 9 is 3 multiplied by 3. So this is going to be 2 times 2 times 3 times 3. And then 54 is 2 multiplied by 27, and then 27 is 3 multiplied by 9, and then 9 is 3 multiplied by 3. So we have 2 multiplied by 3 multiplied by 3 multiplied by 3. One thing you may be asking yourself is there another way to do it if I'm to decompose these numbers if I'm not too sure of the prime factors? Let's take some example. Let's try 36 some other way so you can see that you don't have to always know You can start from what you know and then decompose them to prime factors. So 36, one thing we know for 36 is you have 6 multiplied by 6. You can break this up actually. 2 multiplied by 3, 2 multiplied by 3. So these are your prime factors. That's another option if you are not familiar with breaking it up from the prime factors at the beginning. So let's try 90. 90 is, let's use that method. We have 9 multiplied by 10. So we decompose 9 to 3 multiplied by 3 and 10 to 2 multiplied by 5. I have a habit of always starting from the smallest prime number. So we're going to go 2 multiplied by 3 multiplied by 3 multiplied by 5. So the greatest common factor, we can see 2 is consistent. Now let's see, we have 3 consistent here multiplied by 3, and then we have another 3 that is repeated for each one multiplied by 3. So this is going to be 2 times 3, 6 times 3, which is 18. So the greatest common factor of each of these numbers is 18. Final example. What is the greatest common factor of 42, 72, 108, 150? So what I'm going to do with this example is I'm going to use the method for creating the factor trees that doesn't require you to know the smallest prime factor. So we're going to start with 42. One thing we know for 42 is we have 6 multiplied by 7. So 6 we can decompose to 2 and 3. So 42 is 2 multiplied by 3 multiplied by 7. Now let's go to 72. We have 8 multiplied by 9. 8 we can decompose to 2 multiplied by 4, and 4, 2 multiplied by 2. And then 9 we have 3 multiplied by 3. So you'll see why sometimes I don't like this method. I like the method where you start with the lowest or the smallest prime factor. So we have 2 multiplied by 2 multiplied by 2. That takes care of 8. And then 3 multiplied by 3. So 108. Let's try that. 108. We have 9 and 12. 9 is 3 and 3. 12 we have 2 and 6. And 6 we have 2 and 3. So we have 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3. Now 150. We have 3 and 50. 50 we have 2 and 25. We also have 5 and 5. So let's try 150 another way. So 150 we have 10 and 15. 10 we have 2 and 5. 15 we have 3 and 5. So this is going to be 2 times 3 times 5 times 5. So greatest common factor, we're going to look for numbers that are pair, the prime factors that are pair for all 4 numbers. So we have 2 right off the bat, 2. So we have 3 here, we have it here. So we have 3 also. We don't have 7 anywhere else. We don't have 5 anywhere else. So this is going to be 2 times 3, which is 6. So the greatest common factor of this set of numbers is 6.